agent and ethanamide. Okay, and then of course the OH has on it have the other component being formed, right? But this will be the main thing that we are looking at. So that forms water in addition. Okay. Now if you look at this one, because we have H2 plus here going to add to this to form water. Alright, so heating can let all the various equations come into play, all the various reactions made possible by heat. Okay, strong heat. Now we have the acid with base. Acid reacts with base to form salt. So that's the salt formed, NaH. Na replaces the H in nitrogen. If you heat, keep on heating. Like we said, the two bonds are A not done can break. But here, if this one breaks, the Na cannot add onto the carbon bond. Okay, so that may not like it's not likely. So this one will break, and then you can have the gas form of the carbon being formed. Then you have the CO2 forming the carbonates, and then water being generated. Right. Alright, so let's look at these three reactions too. So we have the acid here. This is the acid, okay, reacting with alcohol. And in the presence of heat and then sulfuric acid. Okay, so what is going to happen is these are the parts that can take part in the reaction. So this is it. Okay, so this is more or less like the negative, and this is the positive. One here is positive, and this was the negative. Okay, right. So the acid can sort of here we have this. Okay, so the acid is adding its OH to this one. This one is providing OH because this is polarized, is adding more OH to it, making this bond ready to go. This one, of course, is also, but let's see which one will be relative. Now, in the presence of this ready to go, if we have a pushing, another nucleophile, a negative, what do you call it, a negative compound that can push, which is positive now, the carbon atom, which has become slightly positive, that can push its way into it. It will help displace this one as well. So, and this can come from the ROH, which is ROH minus. So it can come here, displace this one, and then we'll get this being from an ester being from. Okay, so this will be ester. Right. So that will be in the presence of H plus. The H plus is helping to make the OH leave. Create an OH leaving group, okay, which can leave as water. Now when you come here, the SOCl2, this one creates a positive center. Okay, creates a positive center. So positive center, like that is an electrophile. So an electrophile going to attack. Okay, this is what we have. This is the negative one. So it cannot. This is a positive one. It cannot attack this one. It's positive. So it will come here. The S attacks here with its OH and then Cl. Remember, once it attacks here, it's making this one more or less a group ready to leave. Okay, ready to leave, and this is negative. This is the chloride is negative, so that chloride can go into this part. Now, if this is a strong supplier of chloride, what do you call it, a radical or anion, then that can push into, that can attack the positive carbon or carbocation here, which is the electrophile. Okay, you can attack it and then cause this one to leave as a group. Okay, so when it comes here, then we're going to have Cl attaching to this one to form this. Okay, and then this one leaves. It still has a lot of Cl there which can add onto this to form an acid, HCl. Of course, this one is the acid component is going. Okay, the HCl is already floating in the system. It can react with another HCl in the presence. One HCl will go in, the other HCl can combine with the H plus in the medium to form HCl. And that is what we will have being formed. Right, so that's the thio kind of chloride that we are seeing. So let's look at the next one. So this one, these two, the next one. Here we have the ester. Ester is here. Now look at this lithium aluminum hydride. This hydride is the H hydrogen anion. Okay, so hydrogen anion. This is a good giver of hydrogen anion, so it can and it's a good giver of hydrogen anion. It also creates a positive center. So this positive center can add on aluminum 3 plus, can add on to this, making this bond weaker, ready to leave, and this is positive. So the hydride anion can then go in, so I have this displaced, okay, this displaced like that. This will be displaced, okay, and then this has one. It has more H plus, so that H plus can add on to it, and then you can have alcohol being formed, and then you have another alcohol being formed. Right. So that is for this kind of reaction. So lithium aluminum hydride in ether. Ether is a good medium, a solvent for the reaction. So in that case, water is not there, so that water will go in this place, and then you have acid being formed. Okay, so you use ether. Then the second process, when you go on for a while, you add water, because you need water to generate your RH. Okay, right. So that is how the reaction goes. Okay, so let's look at the next reactions. Now let's look at the two reactions here. We have the acid plus base, so that will form a salt. The salt is formed. Now if you add this one, remember this one has a positive and this has a negative one. Okay, this is the halide of the aldehyde. Okay, halide aldehyde. Okay, right. So so this can use this one to attach this one. Okay, or you can use this one to attach to the OH here. Okay, if you use this one to attach to the OH here, then Cl will come in and it will be same to that will be generated. So it's not likely that's the next reaction point. But if he uses this one, he uses this to attach to the OH here, to the CO here. So if this one is attached to the CO here, okay, as we've seen here, then what will happen? The OH here, this is what is happening. The OH here can go, this bond can go, this can bond, and then this will go with the OH, the Na, and form N, so that we have, this is the this is the alkanoic acid and hydride, okay, alkanoic acid and hydride, okay, or dicarboxylic, so 2 carboxylic acids, okay. Right, now here, when it comes to this one, 2, let's look at 2. This is an amide, this is an amide, okay. So the bond in, like the bond, this kind of bond can be found in amino acids, okay. Now this is a good provider of hydrogen anion and also hydrogen free radical. So let's see what happens. The positive charge is on aluminum, okay. Now this has electrons, free lone pair electrons, okay. So the Al plus can attach to this, making it a good living this thing, or at the same time providing H minus, which can go into this one, okay. So the H minus can go into this, so that maybe the first one that we form is an aldehyde like that, have an aldehyde formed. Remember we have more free radicals in there, they can attract, this one to form water, and then form attract this one to form water, and of course this one that has been formed, this one is still hanging. This model that has been dissociated can also attack as a nucleophile. So either this one is attacking, or NH2 plus, which is a nucleophile now a lot, can also attach. When it attaches, then you form the same amide will form again, but at this point, this OH, the OH here, will be about to leave because this can add on to it. It is now pushing. This forms like that, okay? Or the same way we can also see that lithium is can provide another positive listen. So once this one attaches, lithium can also attach to this one by forming a bond, making this weak, and then of course this one also weak. Okay, this breaks, and then you can have this one attaching to form the amine here. Okay, right, so you can look at first. You have to first look at the positives which can attack, look at the negatives which can attack. But of course, the resultant should not be the same product. So you vary it, and then you'll be able to get this final answer. Right, so that is that, okay? But this will be full of what? Free radicals, halide coming in. Because, and then this, that is going to be a living group, can attack in the process. Okay, can come back to attack, and then the OH can be dislodged. Right. if it comes back to attack, it will form the same thing. And so that means that reaction may not go. So the next thing is to let your negative distance attach here. Okay, so H minus, halide is attacking this one, causing this one to leave, to break. Okay, this breaks. Now once this one breaks, the formed ammonia can also come to attack, to form an imine in this form. Okay, so suppose that these are strong generators of the hydrogen anion, free radical, and positive centers, the reaction can go to what you want. Right. This last bit, this is an ester. Okay, it can be fat or vegetable oil. Okay, if you react it with base, so the sodium will add on this side. Okay, so this OH here is going to displace this one. Okay, it's going to attack this one. So this may be a good leaving. It will leave. This will push it. It will leave, and then you have the NH plus adding to the acid. And then whilst this one, the leaving group can form the alcohol or the other components. Will form the alcohol or the other component. But this is what we call the sodium alkanoate. So sodium alkanoate. The salt of alkanoate becomes the soap. Okay. That is the soap. But remember, powdered soap is what we call, or watery, or this kind of powder and so on, called the detergents. The forms can also be prepared through the same or similar processes. Okay, so the soap is the hard one. Right. So that is how soap can also be formed. Now the last bit of the discussion. Now what you should notice, so this one is an fat and vegetable. Okay, so this from natural product, natural ester. Then that will be called soup. If it is from artificial or petroleum kind of carbon, which is going to react with another to form soup, then that becomes what we usually would call the synthetic detergent, or usually we call the detergent. Okay, so the soap is the hard one, then detergent will be those prepared from the artificial kind of similar fat and then vegetable. Okay, right. So that will bring us to the end. Now, how does soap clean dirt? Because it will have, this part is polar, this part is non-polar. The R part is what? Non-polar, but this part is polar. So the polar part will react with water, will dissolve in water. The non-polar will dissolve the part of the dirt which is not polar. Okay, so in that way it will separate it. To separate it, it will cause the dirt to be dissolved in water and then it will be washed off. Right. So that is that. So it cleanses or cleans the distance by wetting and then forming an emulsion. An emulsion is where you have a water and lipid interface. Okay, so bipolar, because this is a bipolar, this part is charged, one part is charged, the other part is non-charged. So non-polar, this is polar. Okay, the polar part will react with water. Okay, the non-polar part will react with the lipid part. Okay, and then form what you usually call micelle. Okay, so by this process we say there's emulsification. There's emulsification. So the soap, this is the soap, having a polar part and non-polar part, so that it can interact with the polar solvent or the polar thing, and then this part can interact with non-polar thing. Okay, and then be able to, so depending on what kind of dirt it is, it can interact with it and then allow it to be washed in water, or allow it to be washed, the dirt to be carried in water or washed away. Right. So usually the dirt may be attached to the oil. Okay, so let's say we have a surface, we have oil, and then the dirt is here. Okay, the soap can dissolve in the lipid here, the lipid which is non-polar. Okay, right, and then it will also dissolve in water. By doing so, it will wash it off the surface, because this will be carried by the water, and then it will wash off the surface of the one that you are cleaning. Right. So it means it's more or less, it dissolves the dirt by using the lipid that the dirt is attached to. Okay, and it's washed off. Alright. Now just briefly, hard water will contain a lot of ions, cations. So you have the calcium 2 plus, and then all the other ions in there. Okay, so if you have a lot of this in water, when you wash, it will not be easy for the soap to form the soapy kind of thing that you want. Okay, the reason it first has to what first it must react or take care of the calcium in it. So the soap that you are using must first of all take all the calcium off or out of the water, the hard water, before it can start giving you a soapy kind of solution or a soapy kind of liquid. Okay, so by doing so, if you are washing using the hard water, you see that it will not lather easily. Okay, so for it to lather, it must take out or combine with the calcium and take it out of the water before the washing can be effective or lather easily. Right. So of course, hard water containing these minerals will make it a very good source of water for minerals. If somebody has deficiencies in calcium and then the other minerals, then taking hard water will be okay. Right. Now let's look at another part. We are going to look at what we call polymerization. Polymer. So polymerization simply means adding units together. So let's say I have this unit, I add another unit, add another, then I'm adding, that is polymerization. Okay? So you can have amine here. Let's say this is an amino acid. In different forms. Let me just clean this one and draw it better. Now let's look at how polymerization. Okay, so this is a glucose molecule. This is another glucose molecule. Now this is an aldehyde. Okay, it's an aldehyde. So it has its OH, the alcohol group. The alcohol group will attack by being a nucleophile. It has slightly negative charge. It will attack this one, which is slightly positive, because this is pulling electrons. Okay, by doing so, it will form what? And more or less like a compound here, like this. As if it's an ether kind of structure. Okay, this is the compound that it forms. Okay, and then when it does that, this will open up as minus, as -1, or it will open up as minus, and that can also, this is a nucleophile, so it can link with another positive charge on this side of the next, the last but one carbon, okay, to form a bond, right? So then you have this kind of bond, and in the formation you have what? In doing so, you have another structure being formed like that, okay, and this will, you can have a lot of these reactions coming together to form a polymer, okay, and that can be, an example can be cellulose, okay, so a very long polymer can be cellulose. First, you can have the other ones, you can have sucrose, depending on what is reacting with. You can have sucrose, that is glucose and then fructose together. Glucose will be maltose, okay, then as you go ahead, you can come to cellulose, right? The same thing can happen in the case of the amino acids, okay? In the case of the amino acids too, in the case of the amino acids too, the same thing. So we have the CONH, okay? This can react with another amino acid. Let me give this one, which will be a better example. Right, we are saying amino acid, so this, we have the amino here, amino group here, okay? So this is an amino acid, so this is OH here, okay? So this is the amino, this is the amino acid, okay? Reacting with, so we can have the amine group, here, this is our C, and C, with the next C, so okay, and then can have the other ones coming like that. So this bond, this is an imine, and then this one, they can react, okay, through the release of H2O. Okay, so that's kind of an addition kind of reaction. So this is going to form what? C, and have NC, so that's C, and then when you have COO, that can also form another bond, so NC. Right, so this bond can go on. So this one amino acid, another amino acid coming together will form a peptide. Okay, then it can go on to form what? Polypeptide. Polypeptide can go on to form protein, which is the longest chain. Okay, so in that order. So these are some of the reactions. Right. So we are coming to the end of the discussion. So here you can have the polyene, so that's like ethene. So this bond will go, and then hydrogen will be added. This bond will go and link with another CC. Okay, so this will bring it here, this will bring it here. Then this one will become a free radical. They link a lot of them. So this is an addition reaction. Okay, so polyene or polyethene, polypropene will be addition. The double bond will be adding. Polyvinyl double bonds will be adding. Now we come to the condensation reaction, which we have already talked about sometimes. Condensation. So the condensation reaction, water is released. Okay, so here we have the amide. The amide, which is this. Okay, we're reacting with another one, which is let's say here we have an OH here. Okay, let me draw it better. Right, let's look at the amine group, the polyamide. Okay, so the resultant is a polyamide. Sorry, drawing it. That's not it. Okay, the resultant is the polyamide. Okay, so this is it. So you have your C here, another amide here, and then you have the chains following. So the chains can follow. You have another amide forming. So this can be repeated. So this will be a polyamide. This is amide group. Okay, polyamide. Right. So when you have this one formed, this can be formed from an amine plus what? 2 amines and then let's say 2 carboxylic acids. Okay. So they will undergo condensation. So this is like an acid-base reaction. Water is formed and then an amine bond is formed. So you have a polyamide. This one is not an polyamide. So you have a polyamide, which is an example is nylon. Okay. Another example of a condensation reaction is the bakelite, which is a very strong rubber. It has it's a thermosetting kind of plastic. Okay, that is very strong with a lot of cross links. Okay, and then it can also serve as insulator. Right. So very strong, can withstand the stress. It can serve as insulator. Okay. Right. That is the bakelite. It's a very strong one of the, around 1900s. It was the first plastic that was made. Very strong. Right. So this brings us to the end of the discussion. Of course, remember when we're talking about the polymers, the sugars. Okay, the sugars can come together. Glucose, a lot of glucose can form rather starch. Instead of the one we talked about it when you have a lot of glucose in the system. So glucose to glucose a lot, we form starch. Okay, and starch we can use iodine to identify starch. Okay, you can use iodine in the lab to identify starch, so that you have your typical color appearance. All right, so this brings us to the end of the discussion. So we'll first of all look at the addition reactions, the condensation reactions, and then the various methods that we talk about in chemical reactions for carbon, the organic compounds. Okay, free radicals, cation formation, nucleophile to attack, cation to electrophile to also attack. They are all the stability of the double bonds in benzene. And then if they are not stable, it means they are not more reactive, or they are not very reactive. Okay, you compare that with cyclohexane and then cyclohexene. Okay, right? So this is a good recap for organic chemistry, right? We'll take the various workups as we discuss the other topics. Thank you very much.